7.3 is on simplifying expressions, rational expressions with addition or subtraction. Like I've done with every other unit, I'm going to talk about a simpler case first. Remember, when you're adding fractions, you have to have a common denominator. Here the 4 is the same, so we add the top, and the bottom stays the same. 3 plus 5 is 8. 8 over 4 is 2. That can reduce down to just 2. When you have a common denominator on the bottom, you just add up the top. Same thing here. I have a common denominator on the bottom, so I put the top together. And you have to be very, very careful about this subtraction right here. This subtraction has to distribute to everything. A very common mistake is to not distribute that fraction. So the top of this will actually become 2 minus x minus 5, and the bottom stays the same, it's just x minus 5. The denominators don't change, the numerators do, and I simplify. 2 minus x minus 5 is actually negative x minus 3. It kind of looks like this could reduce somehow, but it can't because of the additions or subtractions. We just know that x cannot be 5. If you have a common denominator, you just change the numerator. Now on this third one, it kind of doesn't look like we have a common denominator because these are similar but not quite the exact same. Please note, I cannot cancel anything right now. I can't try and cancel these a's or these 2's or these a's, and nothing can cancel because of all the addition or subtraction. You have to cancel whole entire factors. And what I can do though is recognize that these two things are just opposites of each other. A minus 2, 2 minus a. And if I take the second fraction and I rewrite it so that it's on top still a plus 2, but on the bottom I make it negative a plus 2. So I have this now. I just flipped the order of these two things around. Now what I can do is factor out a negative. I pulled a negative 1 out of this thing right here. That made these match. And now these negatives can cancel, making all this a plus. And I get a plus 5 plus a plus 2 over a minus 2. Now a plus 5 plus a plus 2 is 2a plus 7. A minus 2 is still a minus 2. And I know that a cannot be 2. Now, I don't think I went about that in the clearest way possible, so let me try and simplify this down a little. If ever you have two things that are opposites of each other, make them the same and switch the sign. Okay, I flipped this around, which is going to cause this minus to become a plus, because it's like I'm factoring out this negative 1. So I'll make a quick example. If I have 3 over x minus 1 plus 4 over 1 minus x, I'm going to make this 3 over x minus 1 minus 4 over x minus 1. I just switch that sign to make these match. That only works if these two things were already opposites. That become negative 1 over x minus 1, and x cannot be 1. When you have an uncommon denominator, you have to get a common denominator. We'll spend a few videos on this actually. I just want to introduce the idea right now. Again, here's a simple example of fractions that don't have a common denominator. So what we would do is we would say, okay, these can both go into 20. So multiply this by 2 over 2, and this by 5 over 5, and that gets me 15 over 20 plus 14 over 20 to get 29 over 20. Well, what you're really doing here is you're looking at the number 4 and the number 10 and seeing what do they have in common, what don't they have in common. Like 4 is really 2 times 2, and 10 is really 2 times 5. They both share a 2. This side on the right needs another 2 to make up for this one, and this on the left needs a 5 to make up for this one. They both really need 2 2's and a 5 to get to 20. So you're trying to make the two denominators have the same pieces, have the same parts to them, so that you have a common denominator. We can kind of play the same game when we have these rational expressions. X squared minus 4 is going to become x plus 2x minus 2. I can factor it. Right now, they both share an x plus 2 term. I need to make this have an additional x minus 2, which I'll multiply the top and the bottom by, to match up with this x minus 2 over here. That gives me 3 over x plus 2, x minus 2, plus 7x minus 14 over x plus 2, x minus 2. I can put all that together, and I get 7x minus 11 over x plus 2, x minus 2. We will talk a lot more about this common denominator action in the future. I just kind of wanted to expose you to it right now. Thank you. Have a nice day.